So in the previous lesson, two equations were given. The first one was the differential equation, and then the second was the solution to the differential equation. Now the second equation consisted of arbitrary constants, thus we call that the general solution or the primitive solution to the differential equation. Also in the previous video, we were asked to show whether or not the solution was actually a solution to the differential equation. Now in this video, so what we are going to do is, given the general solution, we are going to accompany that with certain conditions to help us to find the particular solution to that differential equation. Now to clearly understand this, let's consider this the differential equation. So we have the differential equation dy dx equals 5. Now this represents a straight line with a constant gradient value of 5. So what do we do? Let's try to find the original equation where this differential equation is coming from. So what we are going to do is, we have dy dx that is equal to 5. So here we can cross multiply, and then when we do so, we have 1 times dy, and that is equal to 5 times dx. Now at this point, let's try to integrate both sides. Now the integral of 1 with respect to y is y. So we have y equals, when you integrate 5 with respect to x, then you have 5x, and then whenever you perform integration, you introduce a constant value c, where c is an arbitrary constant, and then c can be any value. So c here can be any value. So we can consider c to be 1, c to be 2, c to be 3, and so on and so forth. So if c is 1, 2, 3, then what this primarily means is that we can have the equation, the original equation, to be 5x plus 1. We can as well have it to be y equals 5x plus 2, or better still, y equals 5x plus 3, and so on and so forth. Now the interesting thing here is, whenever you differentiate any of these three equations or these three functions, you are going to arrive at this differential equation. Now what this primarily means is that this function or this equation is called the general solution. So general or primitive solution to this differential equation, and this general solution gives a family, it gives a family of solutions. Now in this video, we are not interested in this. Our interest is to find the particular solution to this differential equation. Now in order to do this, then we need to specify certain conditions in order to arrive at the particular solution. Now what do we mean by finding the particular solution? It means that we need to find the actual value of c. So how do we find the actual value of c? That is where we are going to apply certain conditions. So mostly the two usual conditions that we know is, first of all, the initial value condition, and then secondly, the boundary value condition. Now let's talk about these two conditions. So for any differential equation given along with subsidiary conditions on the unknown function y and all of its derivatives, 1. If the subsidiary conditions are given at the same value of the independent variable, so if they are given at the same value of the independent variable, then we have an initial value problem, and thus the condition is called initial value condition. So initial value condition. So if the subsidiary conditions are given at the same value of the independent variable, then we have an initial value problem, and thus the conditions are the initial value conditions. So a typical example is given the differential equation y prime prime plus 2y prime equals e to the power x, and then we specify the conditions y of 0 equals 1, y of, or better still, y prime of 0 equals 2. Here you realize that we have the same values for the independent variable. Now, since the subsidiary conditions are given at the same value of the independent variable, it means that this problem is an initial value problem, and hence the conditions are initial value conditions. So this is a typical example of an initial value problem. Secondly, if the subsidiary conditions are given at different value, if they are given at different values of the independent variable, then we have a boundary value problem, and thus the conditions are boundary value conditions. An example will be, still considering the same differential equation, y prime prime plus 2y prime equals e to the power x. This time you have y of 0 equals 1, and then you have y prime of 1 equals 2. Here you realize that the subsidiary conditions are given at different values of the independent variable. So in summary, what we are trying to say is that the general or the primitive solution gives a family of solutions, that is, a number of solutions. However, for us to arrive at the particular solution for a given differential equation, then it means that certain conditions needs to be specified. That is, we can either have the initial value conditions, or better still, the boundary value conditions. Now let's move on as we solve a couple of examples. So we are going to take two sets of examples. This happens to be the first set. Now let's try to solve these questions. So we are going to use the given initial conditions to evaluate the constant c in the following equations. So on the left hand side, we have these to be the general equations, or the general solutions, better still. And then on the right hand side, we have the initial conditions. So based on the initial conditions, we are going to evaluate the constant c in the following equations. So let's try to solve these questions together. So for I, we are given the general solution y equals c times e to the power x minus 1, where y of negative 1 is equal to 0. Now what this primarily means is that x is equal to negative 1, and then y is equal to 0. So let's try to solve for c. So basically we are going to substitute negative 1 and then 0 in place of x and then y respectively in this equation. So we have y to be 0 on the left hand side. So we have 0 equals c times e to the power negative 1 minus negative 1 minus 1. Now let's simplify further. So we have 0 equals, now c times e to the power negative 1 can be represented as c over e. E to the power negative 1 is the same as 1 over e. So that is what we have here. And then we have negative, it becomes positive, minus 1. So it cancels out. And then we have 0 equals c over e. Now we cross multiply. We have e times 0, which is 0, and then 1 times c, which is c. Therefore, we have the value of c to be 0. Now let's move on to II. Here we have y minus x plus 1 all square equals c times y plus x minus 1, where y of 6 is equal to 7. So here x is equal to 6, y is equal to 7. Let's plug these into the equation. So we are going to have y, which is 7, minus x, 6, plus 1 all squared equals c times 7 plus 6 minus 1. Now 7 minus 6 is 1. 1 plus 1 is 2. So we have 2 squared equals 7 plus 6 is 13 minus 1 is 12. So 12c. So this is equal to 4. That is 4 equals 12c. We divide through by 12 and then we have c to be equal to 1 over 3. So 4 goes here once, 4 goes here 3 times. So that is 1 over 3. Now let's move on to III. So for III, we have the general solution x plus y times e to the power x cubed equals cy, where y of 1 is equal to 1. So x is equal to 1, y is also equal to 1. X is 1, so 1 plus y is also 1 times e to the power 1 cube equals c times 1. Let's simplify this. So we are going to have 1 plus, now 1 cube is still 1, so we have e to the power 1 times 1, and that is still e to the power 1, or better still e, and this is equal to c times 1 is c. Therefore we have c to be equal to 1 plus e. And then lastly, that is IV, we have the general solution x equals y cubed plus cy, where y of 0 is equal to 1 over 2. So x equals 0, y equals 1 over 2. So we plug these values in this equation. We have 0 equals 1 over 2 cube plus c times 1 over 2. So that becomes 0 equals, now 1 over 2 cube is 1 over 8 plus c times 1 over 2. So we transpose 1 over 8 to the left hand side. We have negative 1 over 8 equals c times 1 over 2. So we divide through by 1 over 2 by 1 over 2, and as we have on the left hand side, it becomes negative 1 over 8 times 2 over 1, and that is equal to c. So 2 goes here once, 2 goes here 4 times, and then we are left with negative 1 over 4 times 1. Therefore we have c to be equal to negative 1 over 4. So now let's move on as we solve the second set of examples. So for the second set, we are going to find the values of c1 and c2 so that the given functions will satisfy the prescribed initial conditions. So here we have 3 questions. I'm going to solve the first one with you, and then you have the second and the third as examples that you are supposed to solve on your own. And we also have the values of c1 and c2 attached to them. So after solving, you compare to see if these values are exactly the same as what you had in your solution. So let's solve for I. So for I, we have the equation y equals c1 times e to the power x plus c2 times e to the power negative x plus 4 sine x. And then we have the initial conditions, y of 0 equals 1, and then y prime of 0 also equals negative 1. Now, here we have y of 0 equals 1. It means that we have x to be 0 and then y to be 1. So quickly, we can plug that in this equation. So we are going to have 1 on the left hand side is equal to c1 times e to the power 0 plus c2 times e to the power negative 0. Now negative 0 is the same as 0. So let's say 0 plus 4 times sine 0. Now let's simplify further. So we have 1 equals, now any non-zero number raised to the power 0 is 1. Notice that this is a constant. So e to the power 0 is 1. So we have 1 times c1, which is still c1. E to the power 0 is 1 times c2, we have c2. And then sine 0 is 0. So 0 times 4 is also 0. So we have 1 equals c1 plus c2. Let's call this equation 1. Now for the second initial condition, we have y prime of 0 equals negative 1. So it means that we need to differentiate this equation. We need to find the first derivative of this equation. So we have y prime to be equal to, now this is a constant, so we hold that, we have that here. And then when you differentiate e to the power x, you still have e to the power x plus, we still have this as a constant, or we also have this as a constant, c2. Now we are going to differentiate this. Now when you are going to differentiate e to the power x, in this case, you first of all differentiate the exponent. Now the derivative of x with respect to x is 1. So we are going to have 1 times, and then you are going to repeat the same thing. So it becomes 1 times e to the power x. That is why when you differentiate e to the power x, you still have e to the power x. Now this time, we have negative x. So when you differentiate negative x with respect to x, you have negative 1. So negative 1 times, you still repeat what you have. So e to the power negative x. So we can simplify this as negative c2 times e to the power negative x. So negative c2 times e to the power negative x. And then plus, when you differentiate 4 sine x, you have 4 cos x. Now since we have this to be y prime, let's plug in the values of x and then y prime. So we have x to be 0, y prime to be negative 1. So negative 1 equals c1 times e to the power 0 minus c2 times e to the power 0 plus 4 cos 0. So negative 1 equals, this becomes c1 minus c2 plus, now cos 0 is 1, so 4 times 1 is 4. We transpose 4 to the left hand side, we have negative 1 minus 4 equals c1 minus c2, and thus we have negative 5 equals c1 minus c2. Let's call this equation 2. Now considering the two equations, we have c1, we have c2 minus c2. So we can add the two equations to eliminate c2. So add equations 1 and 2. So in doing so we have equation 1 is 1 equals c1 plus c2 plus equation 2 negative 5 equals c1 minus c2. So 1 plus negative 5 is 1 minus 5, and that's negative 4, equals C1 plus C1 is 2C1, and then C2 plus negative C2 is 0. So we divide through by 2, and then we have C1 to be equal to negative 2. So that is C1. Now, from any of the equations, we can find C2. So, from equation 1, we have 1 equals C1, which is negative 2, plus C2. We transpose this to the left-hand side. We have 1 plus 2, that's equal to C2. And thus we have C2 to be equal to 3. Therefore, C1 is equal to negative 2 and C2 is equal to 3. So basically, this is how to find the values of C1 and then C2. So you can try question II and then III. We have these to be the answers or the values you are going to obtain at the end of the solution. So that's it for today's video. Thanks for watching, and see you in my next video. Bye bye.